Getting to 11.3 is our second way of solving systems of equations. Well, really third way, but second way that we're going to primarily do with the calculator. So this is different than understanding using the inverses, which we don't even know how they work. This is an actual thing that you can do either by hand that you can verify with your calculator. That works, which is a lot easier when you're working with 3 by 3 or 4 by 4 or 5 by 5. So we are solving equations using something called Cramer's rule. If you want to learn about Cramer, I do not know much about his backstory as a mathematician. I know that he is a more modern day mathematician, and he used determinants in figuring out how to solve systems of equations. So we start off with a determinant. First off, notice that these vertical lines right here are different than our notation that we use for matrices, which are brackets. So this symbol right here means the determinant of this 2 by 2 matrix. And in order which a determinant is just a value. It's a value of a matrix. It tells you something about it. And what it tells you is if you have a matrix that is A, B, C, D, then the determinant of that matrix is A times D minus B times C. We do diagonal minus diagonal. So in this case, the determinant is 3 times 1 minus 6 times negative 2, which is 3 plus 12, which is 15. So the determinant is just some value. And what Cramer's rule states is that if we are given a system, then the solution for x and y is the determinant that looks like this. So we take our standard coefficient. So we take our standard matrix, and this is how this kind of works. So you have your matrix A, B, C, D. We have our matrix x and y, and we have our matrix S and T, which is our solutions, like we did before. So we take the base matrix, and we find the determinant of that. So AD minus BC. And we replace AC with our answer set to solve for X, and we replace BD to solve for Y. So you find the determinant of ABCD. You replace the first column with the answers, and then find the determinant, and then replace the second column with the answers, keeping the first ones. So that's your AC over SD. And then this is your determinant. So you often see this notation. X equals dx over d, and y equals dy over d. I know that explanation may sound confusing, but we're going to try it out on a couple problems, and hopefully it'll make more sense. So using Cramer's rule for solving systems of equations. First off, we're going to write our determinant for d. We're going to write our determinant for dx, and we're going to write our determinant for dy. So the determinant for d is just our normal coefficients, 3, negative 2, 6, and 1. So this is 3 minus 6 times a negative 2. Oh, that looks familiar. That is 15. Now, our dx in this case, we're going to replace the x column with our answers. So 4, 13, negative 2, and 1. So now we have 4 times 1 plus minus 13 times negative 2. So that is 4 plus 26, which is 30. And our dy, our x column stays the same, 3, 6, and then it's 4 and 13. So we have 3 times 13, which is 39, minus 6 times 4, which is 24, which is 15. So in our case, with a different color, we have x equals dx over d, or dx was 30 over 15. And we have y equals dy over d, which is 15 over 15. So in this case, x is 2 and y is 1. Could we have easily solved that with substitution or elimination? Yes. Would we have gotten this exact same information? Yes. When are we going to use this? When we have larger systems that we want to solve for and we want to do by hand. So 3 by 3, 4 by 4, and this makes sense. So unlike a 2 by 2 determinant, to evaluate a 3 by 3, what we have to do is pick a row and then a column, and then another column, and then another column. So this is how it works. We always call the first row I, J, K. Not like just kidding, but that's what we do. So we are going to say the determinant is the first number. So this is I, which is 3, times the determinant of this 2 by 2. So cover up the first row and first column, and we're going to write that determinant. 6, 2, negative 2, 3. So 6, 2, negative 2, 3. Again, we cover up the first column, first row. That's our I. And then it's always minus j. So we take the opposite of, well, in this case, it's 0. I'm just going to write it out so we get it. So that's our first row, second column. So we cover that up, and we get 4, 8, 2, 3. 4, 8, 2, 3. And we're finding the determinant of that. And lastly, it's going to be plus our k. So we cover up the first row, second column, or third column. And we have 4, 6, 8, negative 2. So sorry, our k, which is negative 1. So we don't change this sign. So it's plus, plus, minus, plus. If we went to the next row, it would be minus, plus, minus, and then the next row, plus, minus, plus. And that was 4, 8, 6, negative 2. So in each one of these, we have to do a 2 by 2 determinant times a number in front. So this would be 3 times 6 times 3 minus 2 times negative 2 minus 0, and I'm just going to write this out so we get practice. 4 times 3 minus 8 times 2 plus negative 1 times 4 times negative 2 minus 8 times 6. So this is 18 plus 4 minus 0 times 12. That's what, 12 minus 16, which is negative 4, plus negative 1 times, this is negative 8 minus 48, so negative 56 times negative 1. So this is 66 minus 0 plus 56, which is 122. Now, we did all of that. How do we double check? This is our matrix. Turn on my calculator. So if we go, we can find it in one of two places. If you hit this library button, and you click 1, and I just type the letter D, and scroll down, we see that it says DET, parenthesis. You can just hit enter. We can also find that, if you're curious, if you hit the math button. So if you hit menu, and then you go down to 7, this third option says determinant. We can also create matrices. So we always want this determinant of. Now we're going to hit menu, and we want a 3 by 3, which is what we have. So we have 3, 0, negative 1, 4, 6, 2, and 8, negative 2, 3. Close our parentheses and hit enter. We get our value, which should match up with exactly what we got. So we can do 3 by 3s by hand. I may ask for any exam that you do one by hand. You can check using your calculator. And then when we're solving these 3 systems, 3 unknowns, you give me the setup, and then you just type it into your calculator. Okay. let's flip it over. We're going to do one of these Kramer's rule with 3 variables and 3 unknowns. It's the exact same thing as 2 variables, 2 unknowns. So we're going to pick the first row and then replace the first column, the second column, the third column. The first column for x, the second column for y, the third column for z. All right, let's flip it over. So last question, setting up the Kramer's rule for this system. What we're going to do, this is what you need to do. We're going to set up the D matrix, which is just our coefficient one. So, and I'm going to put the symbols for determinant. So 2, 1, negative 1. Then we're going to have negative 1, 2, 4, 1, negative 2, negative 3. Then I'm going to write out my dx determinant, which I'm going to replace my x column with 3, negative 3, 4. So 3, negative 3, 4. 1, 2, negative 2, negative 1, 4, negative 3. My dy, I'm going to take my x's will stay the same, so 2, negative 1, 1. Replace my middle column now with 3, negative 3, 4. 3, negative 3, 4. And then z's stay the same, negative 1, 4, negative 3. And then dz equals, ran out of room just a little bit here. So the x's stay the same, 2, negative 1, 1. The y stay the same, 2, 1, 2, negative 2. And then the z's we're going to replace with 3, negative 3, 4. So x equals dx over d. Y equals dy over d. And z equals dz over d. Now, if you want to, I'm going to speed this up, but we're going to type each of these things into our calculator. So, if you stay with me for just a second as I zoom in. So we want the determinant of so D is going to be 2, 1, negative 1, negative 1, 2, 4, and then 1, negative 2, negative 3. So D is 5. dx, all I'm going to do is change the x column, so that's going to be 3, negative 3, 4. Hit enter, I get x is 15. I'm going to go back up to my original, and I'm going to change the middle column now. So that's going to be 3, negative 3, 4. I get dy equals negative 10. And then I'm going to go back up to my d, and I'm going to change the z column to be 3, negative 3, 4. Hit enter there. I get z equals 5. So from all of this, x is 15 over 5, which is 3. Y is negative 10 over 5, which is 2. And z is 5 over 5, which is 1. So this, albeit a much longer solution, the exact same setup with a different operation from matrices. So problems are at the bottom, and this is the second to last section for level 11.